We're going to try this again with a different example because the more I played with the other one, the numbers were not working out. So there's a chance that we had something wrong in our regression line. And I don't have time, to be honest, to go back and try to redo all of that work to find that. So I said, I wonder what happens if I look at this relationship here, our number of absences versus the final grade in the course. We had an R value that was big enough meaning close enough to 1 in absolute value, that our hypothesis test showed that we could write that regression line. And here was our regression line for that set of data. I went through and found all of the Y bars and all the pieces that we needed. Let me get my new page here to talk about variation. And so this turns out much closer to adding up what it's supposed to be. Okay, so our explained variation, I can't get them both up there at the same time. The explained variation is the sum of the Y prime minus the Y bar. And so now I'll pull it up, and Y prime minus Y bar squared is 774.71. Okay. Our unexplained variation is the sum of the Y minus Y primes. That thing squared, that's a prime. And so that would be our far right column, which is 30.81. Okay, and if I add that up, I get 805.52. Now the formula says our total variation is the sum of the Y minus Y bars, that quantity squared, and then we add them up. And so Y minus Y bar squared here is 805.34. Okay, I like that number a whole lot better than what we were getting on the other, which to me again means our regression line was probably wrong. So no one's pointed that mistake out to me yet, so once you find it for me, shoot me an email, let me know what I did wrong. Okay, we'll get a correction posted. So then the next topic that we're going to talk about is I just lost my page. We're going to talk about residual plots. When we talk about the residual is the difference between Y and Y prime. Okay, that's the residual. If we look at our spreadsheet over here, the difference between Y and Y prime, okay, this column right here, in theory it should add up to be 0. Again, with the rounding that we have from our regression line and different things like that, our Y is our predicted values. Okay, those were all whole numbers. Our Y primes, if we round these maybe to the 100th instead, or would have taken them out to the 10,000th, it should add up to 0. But this adds up much closer to 0 than the other example. It was like 2, which is not close enough. If we make what's called a residual plot, that's where we put our x coordinates on the x-axis, and which makes sense. And then our y values, we put the residual values instead. So the residual values, sorry, I'm going to click. The residual values are the difference, this column here. So we would plot the point 10, comma, negative 0.1, 12, comma, 0.232, 2, comma, 0.4, or 4.552, and so on. All of those ordered pairs. And then we're going to look at those dots around our x-axis, our y equals 0. Your author shows some pictures there with the dots, and it's on page 574 in your book. And we're looking for the graph that looks like A, where it's a pretty symmetric blob around this line, around this axis here. We don't have very many points. We only have 6 dots. Notice 4 of those dots are below and 2 of them are above. These guys hug it pretty closely. These 2 are I say quite a bit below, but substantially more than the others. And this one is a whole lot higher than any of these are low. So I think my interpretation of this is it would be questionable to use our equation. I can get back and find the equation. This equation here of the regression line, it's kind of iffy whether or not it would be good to make predictions. Okay. All right, I'm going to try to keep these videos a little bit shorter, so we're going to talk about the coefficient of determination in the next video, but I'm going to stick with this example here since something went crazy wrong with the other.